All right, so we're diving into this mountain of articles and videos you've got all about DevOps. And I got to say, it seems like everyone and their grandma is talking about DevOps these days. But if someone put me on the spot and said, explain it, I think I'd just freeze up. You got to change that.
It's true. It's kind of funny. Even the people who live and breathe this stuff, they struggle to nail down one perfect definition. It's definitely more than just, taking the development team and the operations team and like mashing them together. It's a whole new way of thinking about how software gets made.
Okay, so maybe instead of getting hung up on like the dictionary definition of DevOps, we should figure out what problems it's actually trying to solve. Like, why is this whole shift happening now?
Right, right. To really get that, we got to rewind a bit. Remember the days of waterfall development when like projects moved in these slow, predictable stages? Like, ugh, a waterfall.
It sounds kind of rigid and, well, maybe a little painful.
Yeah, it definitely had its drawbacks, long development cycles, not much room to change course quickly. Then agile methodologies came along and kind of shook things up. They put the focus on iterating quickly, getting feedback from users, being able to adjust on the fly.
Yeah, which makes a lot of sense in the tech world, right? Things change so fast.
Exactly. But even with agile, you still had those development and operations teams, and they often struggled to, see eye to eye, stuck in their own worlds, leading to, the drill. Miscommunication, missed deadlines, lots of frustration.
Oh, the classic dev versus ops dilemma. Developers just want to get those cool new features out the door, and operations like, hold on, got to make sure the whole thing doesn't explode when we launch.
Exactly. And that is where DevOps swoops in to save the day, or at least try to. It's about building bridges between those teams, creating a shared language, automating as much as possible, and getting everyone working together towards the same goal, delivering great software quickly and without a ton of headaches. Think about a time you were really frustrated by a buggy app update. DevOps is all about preventing that by improving communication and streamlining the entire development process.
Music to my ears. Nobody likes buggy updates. So how does DevOps actually make that happen?
One of the key things, and it comes up a lot, is something called CI/CD. That's continuous integration and continuous delivery. It's like the backbone of the whole DevOps approach.
Okay, so less about dictionaries and more like CI/CD is the engine making this whole DevOps thing actually go.
You got it. Imagine this system, this well-oiled machine that takes those code changes, tests them really thoroughly, and then integrates them into the main software, all without any major hiccups. That's the beauty of CI/CD.
Got it. I'm starting to see why this is appealing, but you also mentioned, I think, a story about a bank in South Africa. They relied on this super old system for years because the original developer, well, he wasn't around anymore. What happened there?
It's a cautionary tale if I've ever heard one. The bank was totally stuck with this ancient system because no one else knew how it worked. No version control, no documentation. It was like trying to solve a mystery with half the clues missing. That's the kind of situation that good CI/CD practices can help to prevent.
Wow. Yeah, that's a powerful example. So CI/CD, it's not just about speed. It's about making sure that knowledge is shared, code is being reviewed, and updates are smooth and reliable. That's important for, well, basically any organization.
100%. And you've probably even used some of the tools that make CI/CD possible, tools like Git or Jenkins. Think of Git as like a really powerful way for developers to track changes to their code and collaborate with each other, sort of like a super-powered version of Google Docs, but for software. You familiar with GitHub at all?
Oh, yeah, I've definitely heard of GitHub.
Well, GitHub is built on top of Git and Jenkins. You can think of Jenkins as the conductor of the CI/CD orchestra. It sees when there are changes in the Git repository, and then boom, it triggers the whole build process, runs all the tests, and if everything looks good, packages up the application and gets it ready to go.
Okay, yeah, it's starting to click now. But I have to admit, it also sounds incredibly complex.
It can be. That's why a lot of companies now have these specialized roles like DevOps engineers. They're the ones who set up and manage all these processes, the architects and, like you said, the conductors of this whole CI/CD operation.
So, okay, let's say I want to become a DevOps pro myself, big career change, why not? What kind of skills would I need to thrive in that world? What should I be focusing on?
Hold on. Before we go too far down that road, maybe we should walk through a real-world example. One of those YouTube videos you sent, they use the example of deploying a Java application. Could you maybe break that down for us?
Perfect. A practical example is exactly what I need right now. Okay, so walk me through this Java application deployment? Like, pretend you're explaining it to someone who's never even seen a line of code before. What's the first step in this whole DevOps symphony?
Okay, so imagine you're the developer, right? You've just finished writing some awesome new code for this Java app. The first thing you do is commit that code to a version control system. Remember Git, our trusty collaborator.
Yeah, like saving the latest version so everyone's working from the same page.
Exactly. And this is where the automation magic starts to happen. Jenkins, our CI/CD maestro, it sees that the code repository has been updated, and it automatically kicks off the build process.
So Jenkins is like the vigilant guardian, making sure everything stays in sync.
You got it. So Jenkins compiles the code, runs any automated tests that have been set up, and if everything gets the green light, it packages the application into a nice deployable format, which is often a JAR file in the Java world.
So it's like Jenkins is wrapping up the application for delivery, making sure it's all bundled up and ready to go.
Exactly. But instead of just shipping it off to a server directly, we take things a step further. Remember those containers we talked about? Our Java application gets packaged into one of those, often using a tool called Docker.
Ah, yes. Docker. It's like putting the application in a little travel case so it can run smoothly anywhere, right?
Perfect analogy. Containers are like these self-contained units. They hold absolutely everything the application needs to run without any of those pesky compatibility issues. No more, but it works on my machine. Headaches.
That makes so much sense. Okay, so our little Java app, safe and sound in its container. What happens next?
Time for deployment. This containerized application, it gets deployed to a container orchestration platform, and the most popular one these days by far is Kubernetes.
Kubernetes. I've definitely heard that name thrown around, but what does it actually do?
You can think of Kubernetes like the conductor of a really, really big orchestra, but instead of musicians, it's managing hundreds, even thousands of these containerized applications across a whole network of servers. It makes sure they're running smoothly, that they can handle those internet rush hours, and it can even do some self-healing if something goes wrong.
Whoa, self-healing containers.
I
That
know.
sounds impressive. So Kubernetes is like the ultimate babysitter, making sure that our application is always happy and healthy.
I like that. It's taking care of all that behind-the-scenes work so the developers can just focus on building amazing applications without having to stress about the nitty-gritty of server management. And to automate the actual deployment and configuration of our Java application within this whole Kubernetes ecosystem, we use tools like Ansible or Terraform.
Okay, hold on. My brain's trying to keep up.
Mhm.
Ansible, Terraform, what do these tools bring to the party?
Think of them like the master chefs of our infrastructure. They use this concept called infrastructure as code, or IAC, which is basically like writing a recipe for your entire server setup.
So instead of like manually configuring every single server and all its components, you write code to do it for you. Talk about efficiency.
Exactly. It's like having a blueprint for your entire infrastructure. This not only automates the whole process, it makes it repeatable, scalable, and way less prone to, well, human error.
Okay, I think I'm starting to see how all these pieces fit together. We've built our Java app, containerized it with Docker, used Kubernetes to deploy it, and then automated that entire process with tools like Ansible and Terraform. Is that the basic gist of a typical DevOps workflow?
You got it. And this is still a simplified example. In the real world, you'd probably have additional tools and technologies for things like monitoring system health, logging information, making sure everything's secure. It can get pretty complex.
There's always more to learn, isn't there?
Always. But before we get too deep into the technical weeds, I think it's important to talk about the human side of DevOps. Remember, it's not just about tools and technologies. It's about people and how they work together.
Absolutely. One of the experts you had me watch, he really emphasized this idea of learning in public, and that really resonated with me. What exactly did he mean by that, and how does it tie into the whole DevOps world?
Right. He told that story about how he basically documented his entire learning journey online. Even when he was just starting out, he'd share his goals, the resources he was using, the code he was writing, mistakes and all.
That's pretty brave.
Yeah.
Wasn't he worried about people judging him for, not knowing everything?
That's the thing about learning in public. It's about being okay with not having all the answers. It's about embracing that vulnerability and realizing that everyone starts somewhere. By sharing his journey, he wasn't just solidifying his own understanding. He was connecting with other learners, getting feedback, building a network, and showing his passion for the field.
So it's like he was unintentionally building his portfolio at the same time he was learning. That's pretty smart.
Exactly. It's such a powerful strategy for aspiring DevOps professionals. By sharing your projects, contributing to open source code, writing blog posts about your experiences, you're basically showcasing your skills and your passion to the world.
That's a great takeaway. It makes me think about all those times I was struggling to learn something new on my own. Imagine if I'd had a whole community of people to bounce ideas off of.
Yeah, exactly. And that sense of community, it's huge in the DevOps world. People are generally very open and willing to share their knowledge and help each other out.
So we've talked about automation, collaboration, this learning in public concept, all crucial for DevOps. But you also mentioned something called site reliability engineering, or SRE. Is that just another buzzword, or is there something more to it?
It's definitely more than just a buzzword. SRE is like the close cousin of DevOps. They share a lot of the same DNA, but they have their own unique perspectives. Think of it this way. DevOps is the overarching philosophy. It's guiding the entire software development lifecycle, while SRE is laser focused on keeping those systems up and running smoothly once they're out in the wild.
So if DevOps is about building the car, SRE is about making sure it runs smoothly and doesn't break down.
I like that analogy. SRE is all about reliability, performance, and maintaining stability, even when things are constantly changing, which they always are in the tech world.
That sounds incredibly important, especially these days when everything's online and we expect things to just work all the time. But how does SRE actually make that happen?
SREs are like the detectives of the tech world, always asking what-if questions. What could go wrong? How can we prevent it? If it does happen, how can we minimize the impact? They use their engineering skills to build automated systems and processes to try to address those potential problems before they even have a chance to rear their ugly heads.
So they're always one step ahead, anticipating issues before they become big problems.
Exactly. And here's where it gets interesting. A core principle of SRE is actually about embracing risk.
Wait, really? I thought the whole point was to avoid risk.
Well, to a certain extent, yes. But SREs understand that in these complex systems, it's impossible to completely eliminate risk. So instead of trying to prevent every single possible failure, they focus on understanding and measuring those risks. Then they set what are called service level objectives, or SLOs, which define acceptable levels of performance and availability based on what matters most to the users.
So it's about finding that balance between being cautious and accepting that sometimes things might go a little haywire.
Exactly. And this is where the engineering part of SRE really comes into play. They use their technical skills to build these automated systems for monitoring those SLOs, responding to incidents when they do happen, and planning for future capacity needs, all with the goal of maximizing reliability while still allowing for that rapid innovation and delivery of new features.
This is making me think back to that South African bank again. It sounds like if they had embraced some of these SRE principles, it could have saved them a lot of trouble.
Absolutely. If they had adopted an SRE mindset, they would have had systems in place to prevent that kind of catastrophic failure. Things like backups, disaster recovery plans, a team of engineers who really understood the ins and outs of the system. Those are all hallmarks of a solid SRE approach.
Okay, I'm sold. SRE is crucial. But let's circle back to those essential skills for aspiring DevOps pros. Where should someone even begin? What should they focus on first?
Well, the good news is you're already on the right track. Just by being curious and doing this deep dive, one of the most important things you can do is cultivate that mindset of continuous learning.
It seems to be a recurring theme here, and for good reason. The tech world moves so fast.
Exactly. DevOps is always evolving. There are always new tools and technologies popping up. To thrive in this world, you need to be adaptable, curious, and always hungry to expand your skill set.
You're speaking my language. I love learning new things, especially when it comes to tech. But with so much to learn, where should I even focus my attention? What are some of those must-have skills for aspiring DevOps professionals?
Well, based on all the research you did, a few key areas kept popping up. Linux, scripting languages like Python, cloud platforms like AWS, and containerization. These are like the foundational building blocks.
Okay, yeah, that's a lot to unpack. Maybe we can break it down one by one. Let's start with Linux. Why is it so important in the DevOps world? I'll admit, my experience with Linux is, shall we say, limited.
It's simple. Linux is the backbone of the internet. The vast majority of servers powering those websites you visit, the applications you use, even those cloud services we talked about, they all run on Linux.
So to work with servers and infrastructure, you basically need to know Linux. It's non-negotiable.
Pretty much. As a DevOps pro, you'll need to be comfortable working with the Linux command line, managing files and permissions, installing software, just generally navigating the Linux operating system. Think of it like learning the language that the servers speak.
Got it. Linux it is. Now, what about these scripting languages? You mentioned Python specifically. What makes it so special?
Python's like the Swiss Army knife of programming languages. It's incredibly versatile, it's relatively easy to learn, and it's got this massive ecosystem of libraries and tools for pretty much anything you can imagine, from automating those infrastructure tasks we talked about, to building web applications, to even analyzing data. It's a favorite in the DevOps world for a reason.
And from one of those YouTube videos I watched, it seems like Python is especially important for working with configuration management tools, like Ansible, right?
Yeah, you got it. Ansible uses a language called YAML for defining those automation playbooks, and YAML is very similar to Python in terms of its structure. So learning Python is a win-win. It'll help you work with Ansible, plus it gives you this powerful scripting language for tons of other tasks.
Okay, Python's going on the to-do list. Now, what about these cloud platforms? You mentioned AWS. Why is that one so dominant in the DevOps world?
AWS, that's Amazon Web Services, it's like the 800-pound gorilla of cloud computing. They've got this mind-boggling array of services, computing power, storage, networking, databases, you name it. If you can think of a cloud service, they probably offer it.
It's like the entire internet all in one place. But with so many different services and features, where do you even begin? It seems incredibly overwhelming.
Don't worry, you don't need to become an AWS expert overnight. Just start by getting familiar with the core services, like EC2 for spinning up virtual servers in the cloud, S3 for storing and managing your data, and IAM for managing users and permissions.
So it's more about building that solid foundation and then gradually expand your knowledge as you go.
Exactly. And the beauty of cloud computing is that you can experiment and learn at your own pace. Want to try spinning up a virtual server and deploying a simple application? You can do that on AWS for a very low cost or even free with some of their trial offerings. It's a great way to get some hands-on experience without, breaking the bank.
That's really cool. It's like having this giant digital sandbox to play around in.
Yeah.
This actually reminds me of something else that stood out from those YouTube interviews, that emphasis on practical experience over certifications. One of the experts even said that experience always trumps certifications.
He's absolutely right. While certifications can be valuable for, demonstrating your knowledge to potential employers, they're no substitute for real-world experience. It's one thing to know the theory, but it's a whole other thing to have actually built and deployed applications, to have wrestled with those real-world problems and learned from those experiences.
So how does someone gain that practical experience, especially if they're just starting out in the field? It feels like a bit of a chicken and egg problem.
It can feel that way, but one of the best ways to bridge that gap is through personal projects. Remember that story about the YouTube expert, the one who was sleeping in the lab to gain more experience?
Oh yeah, that guy was dedicated. I admire his passion.
Yeah, that's the spirit. Find something you're passionate about. Maybe it's building a website for a hobby you love, or automating some tedious task you have to do at home, or even just deploying a simple application to the cloud. Just use it as an opportunity to get your hands dirty, learn some new tools, experiment with different technologies.
So like instead of just reading about Kubernetes, I should actually set up a cluster and try deploying something to it.
Exactly. The more you experiment, the more you learn, and the more confident you'll become. And don't be afraid to share your work. Put your code on GitHub, write a blog post about your process, maybe even present what you've learned at a local meetup. Remember that learning in public concept. It's such a powerful tool for accelerating your growth.
It's all about getting out there, making mistakes, and learning from them, right?
Exactly.
Okay, this has been incredibly helpful, I have to say. But I feel like we've only scratched the surface of what it means to really thrive in this world. Is it really all about continuous learning?
You've hit the nail on the head.
Continuous learning, it really does seem like the golden rule in the tech world. But it's got to be more than just chasing after every shiny new tool that comes out, right?
You're exactly right. It's about cultivating that growth mindset we talked about. Embracing challenges, not being afraid to mess up. Let's be real. Everyone makes mistakes. And seeing those mistakes as opportunities to learn and get better. The tech world is like a moving target, so being able to adapt and always be ready to learn something new, that's crucial.
Yeah, it's almost like you got to get comfortable with being a little uncomfortable, knowing there's always something new to discover. It's kind of exciting and a little intimidating all at the same time.
That's a great way to put it. And remember, DevOps is all about breaking down those walls between teams and building a culture of collaboration. So on top of those technical skills, you got to be a good communicator, a team player, someone who can bridge the gap between those tech wizards and the folks who, might not speak the language of servers and code.
So soft skills are just as important as those technical chops in the DevOps world. That's encouraging, actually.
Absolutely. Being able to explain your ideas clearly, actually listening to what other people have to say, and working together towards that shared goal, those are essential for building a successful DevOps culture, for sure.
It's like building any strong team, right?
Yeah.
You need that mix of talent and the ability to actually work together, towards that shared vision. So as we wrap up our deep dive here, what's the one big takeaway you want our listeners to walk away with?
Remember, DevOps is not just another buzzword. It's not a fad that's going to fade away. It's a fundamental shift in how we think about building software, a movement that puts the emphasis on collaboration, automation, continuous improvement, and that growth mindset. For people who are willing to embrace those principles, honestly, the opportunities are pretty much limitless.
When we started this whole deep dive, I was feeling a little intimidated. I'm not going to lie. The whole scope of DevOps seemed pretty overwhelming. But honestly, I'm feeling more energized now. It's inspiring to see how these principles, they could be used not just in building software, but maybe even in other parts of life too, in how we work and approach problems.
I love that. And, it makes me think about that question, that thought-provoking question that was at the end of all that research you did. How can the principles of DevOps, the automation, the collaboration, the always be improving mindset, how can those be applied to other areas of your life? That's something worth thinking about.
It really is.
Yeah.
Well, hey, thanks for taking this deep dive with me. I learned a ton. And for everyone listening out there, keep learning, keep experimenting, and whatever you do, don't ever stop exploring.